Here's a CPU that encapsulates all this. We call it NX27V. It's a 64-bit processor, RISC-V plus AndesCore extensions. It has 5-stage CPU pipeline, scalar pipeline. It does have big options, larger caches, 8 kilobyte to 64 kilobyte. Look at the hardware unaligned loads and stores. Most importantly, there are prefetching. DSP or vectors by the nature of the data is sort of sequential, so prefetching relieves some of the pressure on the bus. And then outstanding data accesses. There's a lot of data accesses. There are two ports. There's an axis system port, and then there's a string port, custom port to move the data as well. Vector processor could get the vector unit could get the data from axis as well as string ports. And this is what our CPU microarchitecture looks like. Currently, it supports RISC-V Vector 1.0 release candidate. Supports all the standard formats. Everything Andes does is RISC-V compliant. And then we added a couple of specific data formats for AI, bfloat16 and 4. Those are the sort of AI-specific data formats. SIMD, the computation unit, vector length, it's very configurable, as well as memory bandwidth. We natively support 256 bits. That seems to be the most common memory controller bus with configuration. Vector units, we treat vector unit like a coprocessor in that CPU, once it dispatches instructions, vector instructions to vector unit, we assume it runs to completion. CPU considers that instruction completed. There are multiple operating units. There are 8 operating units plus vector load store unit. Vector unit could do 9 operations out of order at the same time. It's chainable, fully pipelined, so we could do sequential operation. We could load the data from string port. There's a RISC-V vector loads and store unit, and then there's a CPU load store unit, and a streaming unit. Idea is to get a lot of data in, a lot of data out as quickly as possible.